since the open end is a node, going back to what we were talking about at the very beginning, in order to have a node, the wave, the pressure wave that's reflected off of the open end has to get a pi phase shift. If you're going to have a standing wave and you're going to have a node, the reflecting wave had better have a pi phase shift. That way, your reflected wave and the incoming wave will always act deconstructively. Similarly, at a closed end, the sound wave should get no phase shift on that reflection. So what that looks like is right here. So if you say the solid line, there we go. Let's say the solid line is your incoming pressure wave. So at the closed end, we're going to get an antinode, which means we're going to get a large delta P. And at the, sorry, this is not the incoming and reflected. This is the total standing wave at different points in time. At the open end, we're going to have a node, which means that the incoming and the reflected, like I said, they act deconstructively. Do you have a question?
Okay. Yes. I guess I'm just confused about what it means to have a reflection off the open end.
Yes, so anytime you have a wave going from a medium where, so the speed of waves inside of a pipe is slightly different. So anytime you go from a medium where the speed of the wave is going to change, you're going to have a small reflection.
Okay. But isn't it like all air, like inside and outside the tube that it's traveling through? So like, what is it reflecting off of?
You're absolutely right. Would anybody like to give a guess on this one? Michael?
It's sort of like, okay, so in the example where you have the things that are smashing into each other, and at the end of the pipe is open, so it has to be the same as atmosphere. It would seem like at first, like you might be able to just cut off the pipe where you have a buildup of pressure, and then you would be able to have an antinode there. But like the thing we have to remember is that inside the pipe, things are going back and forth because they're limited in their vertical motion. But outside the pipe, like the collisions might be able to, like particles could go up and down as well as just back and forth. So you might not have the like horizontal oscillation, and so that could like degenerate the wave. So you basically have like a different like mu, if you're going to say mu, because not all of the particles are going to just in like the horizontal motion. You also have the speed.
So you're talking about coupling the transverse waves?
Just like not having the constraints of the pipe means that the parts that like a given collision could result in vertical motion instead of just horizontal translation.
I agree that once you're outside the pipe, the motion is no longer constrained to move like this. That is true. Let me see. You can imagine if you had a traveling wave of pressure and you had a maximum at the end right here. And then as those particles, remember they're just jiggling back and forth. So the particles that are at the maximum, some of them are going to go back into the tube. And they're going to knock into their neighbors and create a wave back the other way. So they all bunch up, and as it relaxes, some of them go out this way, some are going to go back this way. And so they're going to knock into their neighbors and create a small wave going back in.